Okie dokie, and we meet again. Video number 8 of our Move Smart Contract Language tutorial. In this video tutorial, we are going to take a look at Bitwise and Bitshift operators. Let's not waste any more time and let's move. Okie dokie, now we are starting to get into dirty water. Nah, just kidding. What we are going to do first, we are going to define the Bitwise operators. Those are the OR, and exclusive OR, XOR. But we need to understand how can we do that? How can we obtain Bitwise values first? How do we solve those values manually so then we can understand what the function is doing? So what I'm going to do, I'm going to build that module and we'll explain Bitwise and then we'll do the functions, okay? Then we'll move to Bitshift, which is very simple. So let me create a new file. This will be sample6 move. And now what I'm going to do, I want to define a module. Module, my address, ADDR, and then we'll say sample6. And so it begins. I am going to do a comment here. Let's talk about Bitwise, okay? Let's say Bitwise. Okay, so there's 3 operators in move for Bitwise. The first one is going to be an OR, the AND, and the exclusive OR, this one right here. Let's explain each one. With an OR operator, what's going to happen is the following. We will provide 2 values that we want to obtain the Bitwise value. When we convert those 2 values to binary, we will determine which Bitwise value is. And we have to determine what that is. An OR operator is going to do the following. If either binary value is 1, return 1. Else, return 0, which means that if either binary value, when we compare both values, if either binary value is 1, we will return 1, else we'll return 0. So let's say we have 2 values. We got value A, which is 7. Let's say it's 7, okay? And then value B is 4. The first thing that we have to do is we have to convert that to binary. I hope that you know how to convert binary, but here it is. We will build our quick conversion table, 8, 4, 2, 1. Now all I have to do is determine the sum in binary to get to 7. That's it. So it's not going to be 8. If we sum 4 times 2, it's 6, times 1, it's 7. So everything else will be 1, 1, 1. Simple, okay? Let's do it for 4. We know there's 4 right here, which means it's going to be 0, 1, 0, 0. That's it. That's how you do binary. Now, we have to say that I mentioned that if either binary value is 1, return 1, which means what? Is this value or this value 1? You can return 1, else you have to return 0. In this case, 0, 0, man, we got to return 0, okay? That will be the first value. Second value is either 1, yeah, so we return 1. Third value is either 1, yeah, we got the upper value, 7, this will be 7, this will be 4, then this will be 1, 1, okay? So the OR value between 7 and 4, when we do this right here, this will be the operator 7, 4 equals what? What's this? We know we can see it already here. It's going to be 7, okay? This will be the OR. Got it? Now, let's do the AND. What will be the AND value? If both values are 1, in this case, I need to make sure that I match like this. I match 1 and 1 so that I can pass 1. Else, it's going to be 0. If both binary values are 1, return 1, else 0. Okay? So now we know this will be 7 here. Now let's do it for AND. Let's remove this here. And for AND, it's going to be 7, boom, 4. And let's solve this. If both binary values are 1, return 1. So this is 0, remains 0. Then this one is going to be 1, return 1. Then everything else will be 0 again because they both have to be 1. So then it matches. Now we know that this value and 7 and 4 in Bitwise, it's going to be what? It's going to be 4. We know that this is the value in binary. It's going to be 4. So we know that this value is 4. Now, finally, let's work with exclusive OR. What does it do? Binary values are different. Return 1, else 0. Okay? Now let's solve the last one. XOR. So it's going to be 7, and this will be the operator right here. 4. Now let's see what that is. If binary values are different, return 1. So this is different. No, then this will be 0. This is different. No, it will be 0. This is different. Yes, then you want to return 1, right? This is different. Yes, you want to return 1. How much are we left with? 1, 2, 2, and 1. So 2 and 1, we turn those on. 2 and 1 is 3. So this will be the XOR value. Got it? Now let's build a function. Let's do it real quick, okay? I'm gonna leave this right here, and you'll have access to all my modules in my GitHub repo in the link below, okay? Let's build that function. Function is gonna be bitwise, or let's do the first one, or A, let's just say A, U64, and then B, U64, is gonna return us U64 because it's gonna return a numeric value, right? And let's just build that formula. It's gonna be return A or B, okay? So it's gonna return the value of that. Now let's do another function, function bitwise and. All we have to change here is going to be this. And then finally, we're going to say function bitwise XOR, exclusive OR. This one is gonna return right here, okay? Now let's build that test, okay? Attribute test only, wanna print. So use std debug print, okay? Now I'm gonna say test function test bitwise. Now we are going to pass let result. We want to capture what the output is, wise or, and we'll pass the same values as I did here. So then we can confirm that what I was talking was true. So we're saying 7, the first, which is A, and then 4, all right? And then we'll say print, point to result. Let me do this, copy, let's say result and print. And finally, the last one is going to be bitwise XOR. And let's see what we get, okay? So I am going to save this, and let's run it. APTOS move test, see what we get. Let's compare. I already know that it is 7, 4, 3. Go back, 7, 4, 3. Awesome. Let's go with Bitshift. Bitshift is very simple. With Bitshift, I'm going to also comment here. Bitshift, what I'm going to tell, I have only 2 operators. Either I can Bitshift to the left or I can Bitshift to the right. What does that mean? It means that I will pass a value that we have to convert in binary, and then I will pass another value that is going to tell how many times am I going to shift and which direction. If I say 7 and I want to shift to the right, this is the operator, Bitshift to the right, and I want to shift 2 times in binary, then what it's the value that we should be obtaining, okay? Bitshift to the right. So I'm gonna say 8, 4, 2, 1, 7. Let's find 7. This will all be turned on. 7 is going to be the last value that is turned on. Then we shift 2 times, okay? So it's going to be right here. So 1, 1, 1. This will be 7. Then this is the last value. Then we shift 2 times. So if we shift to the right, we should be obtaining 1. That should be the value, okay? Let's do to the left. Now we have to shift to the left. So the last value that I had, in order for me to get 7, the last bit on, then it's going to be 2. So it's going to be 8 and 16, which means that I have to say 16, 8. So let me just do this. Right? Now I know that this is going to turn on. Now this is turned on. So this is, disregard this because we're not using those 2. We are using the last one. Then 1 here and another here. So I'm going to say 8 and 4. Okay. We know that all this is 7, right? So this is the sum of all that is 7, but this will be the last bit that is enabled. Then we'll have 8 and 16. So if we add all this up, we should obtain how much? For 8, 16, that should be 28, okay? So that should give us 28. Let's go ahead and give it a shot. Test function, just a Bitshift left, and we'll pass A, which is the value. This will be times. Let's call this times, but keep in mind that this cannot be declared, the times cannot be declared as U64. It has to be declared as U8. That's the limitation. We cannot declare this higher than U8, unsigned integer 8, okay? And this should return U64. This will be the value that we should obtain. And now we are saying return A, and if it's shifting to the left, we just have to do this, times. Okay, so this is basically telling how many times do you want to shift to the left for this particular value. Okay, so we'll pass the integer, it does the conversion, and it should give us this value right here. And now let's do it to the right. Basically, same thing, only difference is going to be this. Boom, boom, and this will be right, okay? Of course, we want to test, so let's build a function to test it out. Attribute test, and we'll say function test bit shift result equals to bit shift left, and we'll print this result, and we'll have to pass the values. So let's use the same example, 7 and 2, right? And we'll copy this, and we want to do it to the right as well, and save it. And we have to close this. That's it. Let's give it a shot. Let's see what happens. And like I told you, we got 28. That was the right, and then 1. We got 28, right? So we got 28 to the left, and then right, we got 1. It's exactly what we obtained here from the output. Awesome. Time for a quiz. Which bitwise operator requires both values to be the same in order for the operation to return 1? Is it A, or? Is it B and C, exclusive or none of the above? I don't think so. If you answer B, you are correct. We have reached the end of video number 8. On video number 9, we are going to take a look at casting in move operations. See you on video number 9.